Good evening, guys. So today we're continuing on sets, and today we'll be looking at subsets. And can anybody tell me what you think a subset is? What is a subset? Let me throw some questions to some individuals. Miss Amanda Scott, what do you think a subset is? All right, Miss, I'm not hearing your response. It seemed like something is wrong with your mic. I don't know if you want to try again. Anybody else? How about Mr. Shamar? What's a subset?
To be honest, not sure, sir.
Okay, not sure. All right. Ms. Cavero, what's a subset?
Sir, a subset is basically part of a set.
Okay. Ms. Clark, want to add anything to that?
I was going to say the similar thing, sir.
Okay.
Same. Yeah.
All right. Anybody else have any different idea that you want to share with us?
Sir, I think subset is a set that are from a primary set.
Okay. All right. So all of you are pretty much on point. So a subset is a set which is formed from an existing set. And so you can always form a set within a set. And so that set is referred to as subset. Now the prefix of here is the word sub. And anybody know what the prefix sub means in terms of English language?
Part of.
Not really. Sub means
Branch.
sub means under. We talk about submerge, submarine. So sub really means under. So a subset really kind of mean a set under as another set or a lower set. That's what it kind of means. A lower set from an existing set. When you talk about a subordinate, you talk about a person who is lower in rank from another person. And so they have to listen to what the person says. All right, so anyways, so in general, a subset is a set within a set. Now the symbol here looks like a C, but it's not a C. This symbol is a symbol that we use when we are representing subsets. All right, so the definition here, the set A is a subset of the set B if every members of A is also a member of B. All right, so the set A is a subset of the set B if every member of A is also a member of B. All right. Now we write it in this way to say A is a subset. Or A with this symbol, it means A is contained in B, which is the same thing as saying A is a subset of B. All right. We may also write it using the symbol the other way around. Now, if we use the symbol the other way around, it's kind of a reading in a different way. Here we are saying B contains A. So when you write it this way, you are saying that B contains A or A is in B. Now, the symbol kind of used similar to how you would use greater than and less than sign. Anybody know which sign is greater than and which one is less than? Which one is the greater than sign and which one is the less than sign? Oops. A second, guys. So if you have a symbol like that and one like that, which one is the greater than one and which one is the less than one?
The top one, sir.
The top one is the greater.
Greater one.
Right. So when we're using the top one, the number that is on the left of the sign, we would say that that number is greater than the one that is on the right. So 6 is greater than 2. But if we use it the other way around, we could say 2 is less than 6. And even though you use it the other way around, they're basically saying the same thing. So 2 is less than 6 means that 6 is greater than 2. Everybody see what I'm saying? So
Yes, sir.
in a similar way, when we're using the subset formula, or the subset symbol rather, it can use in both ways. But when you use it in this way, you're actually saying that A is contained in B. So A is in B. But when you use it the other way around, you're saying now B contains, meaning that B has A within it. All right? So flipping the symbol around, you use the word contains, and when you use it this way, you're thinking of the word contained. So A is contained in B. All right, now, if you think of it in a similar way to the less than and greater than form symbols, you see with the greater than symbol, you can tell which side is greater than by looking at the symbol like an arrow tip. If this, you think of this as the tip of an arrow, right? Then the pointed side is the side that points to the number that is less than. But the back of the arrow tip, which is the open side, point to the number which is greater than. So even if you flip it around, you'll realize that the pointed side will still be pointing to the side which is less than, and the open side, which is the wider side, is pointing to the number that is greater than. So whichever way you use it, the greater one will always be to the open side, and the less one will be to the pointed side. Now, in a similar way, if you think of this subset symbol in the same way, the side with the curve will always show you the subset. So if A is a subset, it means that A is in B. If you flip it around the other side, the curved side still going to point to the subset. And so you are really saying A is in B. Right? So whichever way you use it, the curved side going to point to the one which is a subset. All right, if you understand what the connection that I'm trying to make with the less than and greater than symbol, raise your hand. Let me see if you understand what I'm saying.
Could you go over again, sir?
All right.
I can't hear it, sir. I was just asking. Miss
What was
Green,
that?
sir.
On the screen. All right, so I was saying when you look at the less than and greater than symbol, you notice this looks like the tip of an arrow. Like a, if you draw a line through here, this would be the tip of the arrow. You follow?
Okay.
Miss Green?
Yes, sir.
Right. So we are saying that the point of that tip always point to the number that is less than, no matter which way you turn it. So if you turn it around, the point will always point to the number that is less than. And the open end, which is the side that looks like it opens, will always point to the number that is greater. Even if you turn it around, the number that is greater going to be on that end. You're following so far?
Yes, sir.
Right. So in a similar way, if we look at the subset symbol, the curve end will point to the subset. So the subset is the set that is formed from the other set. So A would be a subset of B because you would form the set A from B, or if it's a set A that comes out of B, right? So when you turn the symbol this way, the curve end is saying that A is a subset of B. When you turn the symbol this way, you're saying that B contains the subset A. You following what I'm saying now, Ms. Green?
Yes, sir.
Right. So just in a similar way, like how we can flip around the less than or and greater than symbol, we can also flip around the subset symbol. All right. So with that said now, we all familiar with how we can use a symbol. So let us move to our next slide. So here now, we're going to be looking at types of subsets. And so we have these types of subsets. So we have one, which we call the improper subsets. And the set that we refer to as improper would be the set itself. So if you have a set and you take the set itself as a subset of itself, then that subset would be an improper subset. So the set itself is an improper subset of itself. The empty set, sometimes they refer to it as the null set, is also an improper subset. So we have the improper subset, which is the set itself, and the null set or empty set. And now we may have what we call proper subset. Now, all the other sets that we can form apart from the set itself and the empty set, those are all proper subsets. And in a little while, you will probably think about them and see why those are proper and the set itself and the null set would be improper. All right, so we say sometimes we are asked to list all the subsets of a given set. For instance, or for example, you have the set A, which is ABC, and then you have the set B, which is 1, 2, 3. And for each set, you are asked to list all the subset of A, and then list all the subset of B. So what I'm going to do for you, I'm going to do A, which is a little easier than B, and then you are going to do B. All right? All right, so to list all the proper subset of A, or rather listing all the subset of A, we are going to start off with the proper ones. So A is a set A, B, C. Now, we can start off with the subsets. Now, when you think about a subset, you're thinking about a set that you can form from an existing set. So from the set A, can you group any members of A and form another set? When you think about it, you could take one person or one member to be a whole set by itself. So you could call A a subset. So A would be a subset of this set because you can take out this member by itself and consider that member to be in a set. Now you could also take out the set B. You could take out the set B, and B would also be a subset. Now notice that the subsets that we are forming, I'm putting them in the curly brackets too as well, because the curly brackets reads, anybody remember what the curly bracket reads?
The set
Is it set after?
The set of, right? So when you read it this way, we are saying that the set of members or the set of symbols A are the set of member B, and we are saying all of these are subsets because these are sets that we are forming from this bigger set. So A by itself is a subset, B by itself is a subset, and C by itself is a subset. Now, can we form any other subset apart from just A by itself, B by itself, and C by itself? Well, we can group them in terms of two members. If we are grouping them in terms of two members, how many groups of two members that we can form? All right, so we can start off with A and B can form a subset. So we put those in one group by themselves. And then we can form what? A and C as another subset. And then we also can group what? B and C as another subset. Now, if you look carefully at each of the subsets, you notice that each of the subsets are unique. They are not repeated. So I know sometimes you might be tempted to say that you may have a subset which is CB, but if you're to write the subset CB, would that be the same as any other subset that we already formed? Which other subset would CB be the same as?
BC.
BC, right, and clearly they have the same members. Remember, when we talk about equal set, two sets are equal if they have exactly the same members. But it doesn't matter how you arrange them, it is the same set. So we don't repeat sets. So even if it switch around the members, once those members already exist in another set, you're repeating the set. So for a subset, we don't repeat them. So it means that How many subsets we have so far from this existing set? We have 1, 2, 3, 4, 5, 6. Now, remember we talk about improper subset. What are the improper subsets now? So these are the proper subsets, and we have the improper ones. We say the set itself, which is ABC, would be a subset, but it is an improper subset. So ABC would be a subset of itself. Which other improper subset we mentioned? Anybody? We say that the empty set is also a subset, but it is an improper subset. Now we can argue why these are subsets. Why would you say that the set itself is a subset of itself? Why can we say that?
Sir, because each member of the set is a part of the set.
Right. So if you think of a class, now from the class, you have students in the class, but from the class, you can group different members to do different things. You might pick one individual student and you call him the class monitor. Then that would be a subset of the class. The class monitor would be a subset. You can take the entire class to be probably on, let's say, you can take the entire class and you may, I'm trying to figure out what we could do with the entire class. You could put them in the choir, right? Now, the set of members in the class would be the same set of members that we have, but now you use them to form another set, which is a set of choirs, right? Now, so what that means, you're using the set itself to form another set, which is a set of choirs. So in that sense, you can call the class a subset of itself. Now, there are days when all the members are going to be in the class, but there are other days when the class is empty, no member in the class. So an empty class means that you still have a set, but it would be a set of no members. So the null set is also a subset, but we don't refer to them as proper subset. We refer to the set itself and the empty set as improper subsets, because based on the definition of a subset, and if you were paying attention just now, you would probably can recall what the definition of a subset says. Anybody can tell me what the definition of a subset says?
Sir, a subset is a set within another set. Taken
Right.
from within another set.
So to have a proper subset would mean that the word sub means a set that is under a bigger set. So when we say sub, you're thinking about smaller groups from a bigger group. So in that sense, you could consider the smaller groups as proper. But when you talk about the set itself is not smaller than itself. So in a sense, it's kind of a improper subset, because you're saying a sub is a group that is smaller than the bigger group. And for you to say that the set itself is a subset of itself, it's kind of contradicting in the sense to say it is a subset because sub means under. It's a set which is under a bigger set, right? But anyways, we may call it an improper subset. Just in a similar way when we talk about a proper fraction and an improper fraction. Because we know that for a proper fraction, you have a fraction is a part of a what? A part of a whole. That's the definition for a fraction. So you're expecting that a fraction should be a smaller portion of the entire whole. But where we have an improper fraction, you realize that the numerator is larger than the denominator. So it means that you can get a whole plus a fraction if you convert that improper into mixed number. So in that sense, it could not be called a proper subset. Sorry, a proper fraction, because a proper fraction, we're thinking of a part of a whole, but for an improper fraction, we know that that is more than a whole, right? But we still call it a fraction. It's just improper. Just in a similar way here, we still call it the set itself a subset, but it's an improper subset. The empty set would be a subset, and it's an improper subset. Now, when you check all the subsets that we have here, how many you count? How many subsets did we just formed? So we have 1, 2,
8, sir.
3, 4, 5, 6, 7, 8. So from this set, we form 8 subsets. Now, you are now required to form the subsets of this set B. We form the subset of A, but now I'm asking you to find all the subsets that you can from the set B.
Excuse me, sir.
Yes, Ms. Traver.
How do you come by the last set?
The last one, the null set?
Yes, sir.
Right, because a set, when we talk about a set, we're really trying to have a group of things, a collection, right? Now, if you are forming other sets from that collection, you can take some of the members and put them in different groups. So you may choose to have a group where there's no member in it. And so that group is legitimately a subset, even though there is no member in it. You follow what I'm saying? Because out of the full class, you can consider the class by itself without member would be a subset of the class. Because you can go in there and just sit in the class, and it would be a subset. That's all we're saying. Is that clear, guys?
So, sir, you're saying, is it that you're saying that because the last one would refer to an empty set?
Yeah. So the last one is an empty set, but it's a subset, but we say it is not a proper subset because it doesn't fit the general definition of a set, which is another set formed from an existing set, right?
So that set will come about automatically for if you're finding the subset of anything.
Automatically the set itself and the empty set, those are two subsets.
Okay, sir.
Right, so once you're finding the subsets, you have to include those in it too as well. All right, so go ahead now and try to list all the subsets that you can possibly find from rearranging these numbers. And remember, you cannot repeat a set. Repeating a set means that they have the same members in them, even if the arrangement is different. All right, so go ahead. I'll give you about 3 minutes to see if you can list all the possible subsets of the set. Whenever you're finished, just raise your hand, and then now we will check your list to see what you have. All right, guys. All right, Miss Cummings, you ready?
Yes, sir.
All right, tell me your list. Let me write them down for you. Which one you have first?
So I have 1 by itself,
All right, so 1 by itself. What else?
then 2 by itself,
2 by itself. What else?
3 by itself,
2 by itself. Remember, you're telling me them and I'm just writing.
and then 4 by itself,
4 by itself.
in another set I have 1 and 2,
So you have 1 and 2.
1 and 3,
1 and 3.
1 and 4,
1 and 4.
and then 2 and 4.
And then 2 and 4.
2 and, yes, sir.
All right, 2 and 4. All right, so my question to you now, are all those the possible subset that you can find?
For now, sir.
For now. All right.
Yes.
There are still some more that you need to search for. So those are some, but they're not.
What about 2 and 3? Isn't that one, sir?
2 and 3. Yes, 2 and 3 is there yet? No.
No, sir.
So 2 and 3 would be 1.
3 and 4 as well, sir.
And 3 and 4.
And the null set.
And the null set. All right. Are those all though? Are those all the possible subsets?
Sir, the 1, 2,
No,
and
sir.
3, and 4 is 1 as well.
Yeah, because those are subsets that you're forming. So 1, 2, and 3 would be 1. Continue. Right.
1, 2, 4.
All right, Mr. J says 1, 2, 4. Any other one?
2, 3, 4.
Be careful not to repeat any though. So you will have